That plus many other factors make the cost of any kind of a fusion power plant of that nature very high. In the case of helium-3, you can, instead of having to use magnetic confinement primarily, you can use electrostatic confinement, because the reaction products as well as the fuels themselves can be ionized. That is, they can have electrical charges and be manipulated by electrostatic fields rather than magnetic fields. And that is very, very important in reducing the capital costs. And we've already talked about the fact that you can potentially eliminate any radioactive waste, and you can probably double the efficiency of the plant over existing power plants.
About 10 years ago, there was a treasure ship. It's in the book Ship of Gold by Gary Kinder. This man named Tommy Thompson raised $100 million to go in and find this particular ship in the ocean. And as he got going, found out that all new types of technology needed to be created to bring it up. So this particular venture is a microcosm, to me, of part of what's going to happen with returning to the moon, which is that as the commitment of finances are happening and the groups or the individuals commit and get going, all these new technologies and capabilities are going to be born from it that are just as huge along the way. And I think that a lot of people don't know that's what happens when you commit to large-scale projects. All new types of applications and income opportunities and inventions and technologies come about along the way. My next question to you is a difficult one. I was wondering why NASA bombed the moon some months ago. I don't understand it, and it has nothing to do with what you're proposing, but do you know why that was done? And if you do, could you share why they did that?
Well, that's an interesting choice of words, bombing the moon. What NASA did was launch off the Lunar Reconnaissance Orbiter, which is currently operating very productively in lunar orbit. They launched off of that spacecraft a probe that impacted into a permanently shadowed part of a crater at the south pole of the moon. And then they had, at the time of impact, they had a large number of instruments watching to see what kind of materials would be released by the mechanical as well as the heat energy of that impact. And hoping to determine quantitatively how much water might be present and other elements might be present in the permanently shadowed parts of the polar regions of the moon. Those permanently shadowed areas are extremely cold, like they're down at just, say, 40 degrees above absolute zero, which is extraordinarily cold, and they act as cold traps for any kind of solar wind gases, water produced by various reactions that might migrate over geologic time. We're talking about billions of years, or millions of years anyway. And they would be attracted statistically into these cold traps. And that was the reason, scientific reason for NASA doing that, I think it was called L-Cross probe that hit into the permanently shadowed crater.
The media is who was writing bombing of the moon. So that's why I used the expression, because I don't know anything about it, and I just saw, NASA's bombing the moon, and so...
It does relate indirectly to the question of what is the distribution of helium-3 on the moon, in that the evidence is very strong now that hydrogen, which also comes to the moon from the solar wind as protons and then captures an electron to become hydrogen again and is embedded in the lunar regolith just as helium is, that hydrogen, evidence is very strong that hydrogen concentrations increase as you approach the north and south poles. And that most certainly is because, again, of cold trapping, that it's just not as hot, and less hydrogen is lost after it's been embedded in the lunar regolith as you approach the poles than would be the case at the equator. If hydrogen is being concentrated towards the poles and in permanently shadowed areas, then helium almost certainly is also. So even though the book analysis that I made relates to the near equatorial concentrations of helium-3 as shown by the samples, the regolith samples brought back by Neil Armstrong. We now know the probability is very high, although we do not yet have samples, but the probability is very high that helium concentrations increase as you go north and south, probably as much as by a factor of 3. And, of course, that would help the economics of mining and processing helium-3 a great deal.
And speaking of mining, you shared about how mining would be an incredible adventure on the moon and that we may need an entire new mining system.
Well, conceptually, the mining will probably be very, not unlike large-scale mine, what we call large tonnage mining here on Earth. But from a technology point of view, you need a great deal more automation than is normally used here on Earth. You're going to need very high reliability because of access for repair is not quite as easy as it is here on Earth. And there are just going to be a number of very interesting and exciting for engineers challenges that have to be met in order to develop these mining machines that can, say, produce 100 kilograms of helium-3 for a 1,000-megawatt plant here on Earth on an annual basis. I have no doubt that those kinds of machines can be developed. They're based on bucket wheel concepts and other engineering concepts that are not new. It's just that you have to make them perform in a very hostile and different kind of environment. Now, mining on Earth has gone into very hostile and difficult environments before here on Earth. And so managing a mining town, if you will, on the moon conceptually has been done before. It's just that the whole thing is being done in a different, shall we say, cosmic environment than what we're used to here on Earth. But many of the concepts are the same. For example, you want people to be permanent residents of that mining town. You don't want to keep having to ferry people back and forth. And so you'll be looking for technicians and miners and scientists who are willing to basically go to the moon to live. And that will reduce the cost significantly and is one of the factors that is important to making this whole enterprise economic.
I think we will also need a new type of bank, and it would be a good place to start on the moon. Maybe Earth can learn from the moon.
Thomas Jefferson told us that a little revolution here and there is not bad, and I suspect that a settlement that develops on the moon with its economy based on helium-3 and other resource development there will at some point decide they want to be independent, at least politically independent of the Earth. They're tired of taxation without representation, and they will probably give us a new experiment in how a new and free settlement can actually be developed in that new environment. It's quite exciting, as a matter of fact.
I love the fact that you talked about everything from radiation and moon dust and needing the suits to be sealed against dust. But I was shocked to hear that dust is more of a concern than space radiation. Why?
Well, space radiation, you know exactly what you have to do to protect yourself from it, and that is put a reasonable shell of water around your habitats and places where you're working, and that will protect you from the solar particle events, and depending on how much you put there, it'll protect you from cosmic radiation to some degree as well. So we know exactly what to do about radiation. Dust is going to be a bit of a more engineering challenge. I say we know what to do. It's just, again, it's going to be an engineering challenge to make sure that this extremely fine abrasive material is kept out not only of moving parts of your mining machine, but also you don't want it to migrate into your habitats. But there again, we have an advantage in dealing with it, in that essentially every one of those very small particles is slightly magnetic. It has little tiny pieces of iron in it, produced by these micrometeor impacts that